Okay, so here we're going to do Grothendieck-Riemann-Roch for threefolds. So let's remember the Grothendieck-Riemann-Roch formula. So how do we remember this? So we have the coherent sheaves on this for coherent sheaves on X, and then there's some base space here, and then there's this push forward. Okay, and then we have these two maps this way. One of them, this is pairing with the Todd class of X and taking the Chern character. Here we take the Chern character and then pair with the Todd class of X. And these both are in the respective Chow rings. And this is the push forward here. Okay, and so this is for a map from X to S, which is proper. Okay. So when we disentangle this information, it gives us the Grothendieck-Riemann-Roch formula. The Grothendieck-Riemann-Roch formula says that this diagram commutes. So we take a vector bundle on X, and then we push it forward and then do this. Okay, so we take this thing, okay, of E, and we do this, and then we do the Todd of S. Okay, and then this is equal to the other way around. So we first do this. We first do this, and then we push forward. Okay, so we have these things, and then this is all functorial, all of this stuff. Okay, and so we're interested in the case for threefolds, and in the case when S is a point. Okay, so when S is a point, the Todd class becomes is just 1. So here's this, and then this part becomes the Euler characteristic. So this is the hard part to compute. Okay, so this just becomes here in our case, this just becomes the Euler characteristic of our vector bundle, which is the alternating sum of the cohomologies, and then here is what we need to compute. Okay, and so in order to compute this, so sorry, this is of E. There's two things that we need to get. So we need to get that what we need to figure out what this is and what this is. So so let's fix some notation. So EI is going to be the Chern classes for E, and actually let me do this on the next page. Okay, so we need the I'm going to write it with a polynomial here. This is going to be R, so the rank E1t plus, so I'm looking at this formula now because I don't remember what the expansion is for these things by heart, plus E1 cubed minus 3 E1 E2 plus 3 E3 divided by 6 T cubed. Okay, so we have, this is for, okay, so this is for a threefold, so X is a threefold, so we don't worry about the higher terms. So the dimension of X is 3. And then we have, the next thing we have is we have the Todd, so the Todd polynomial, the Todd class, okay, is 1 plus C1, so over 2 plus C1 squared plus C2 over 12. So T squared plus C1 C2 over 24 T cubed. Okay, and so again, its dimension is 3, so we don't worry about this. And remember that, so here I'm using the notation, so EI is CI of E, okay? And so this vanishes when you go past the rank or you go past the dimension of the base space. And CI is CI of X, and this is equal to CI of the tangent bundle of X, okay, by definition. Okay, so we have these two pieces of information, and now we want to put them together, or we essentially want to take their product. So here, this is of T, so I guess this should be of X, Todd class of X. Again, sorry about the mistake. So this is this. Okay, and so now we need to take the product, and in the end, we're only going to be caring about the degree 3 terms, the top terms, and the rest of the terms are going to vanish. So we need to go with the top terms, and so we need to pair this one with this one. So I can just go and we can find that, so what I'm going to write? I'm going to write this times the Todd of x. Okay, so this is going to be equal to, so this one times this one, r times c1, c2 over 24. And then, okay, so I'm going to drop the t squared, okay, the t notation. Okay, so then we've taken care of this and this. Now we need to do this one and this one. So plus e1 times c1 squared plus c2 over 12. So not t squared, so I said I was going to drop that, plus, okay, so now we need to do this term and this term here. So, okay, this is a t plus. Okay, so this one and this is equal to c1 over 2, e1 squared minus 2e2 over 2, okay, over 2. Okay, so we have this term, and we have one last term, which is this huge guy here. What should I use? I'll use a round thing, and this goes with 1, plus, and then we have 1/6 e1 cubed minus 3e1 e2 plus 3e3, like so. Okay, so we have this formula here, and this is essentially what it's going to be. So so this is actually the formula for this, because this is going to get rid of all the lower dimensional things. So we want things in pure codimension or pure dimension 0. That's the stuff that's going to live after applying this map, because we're going to a point. And this gives us the formula. So the formula, we go back to here, the growth and decay Riemann-Roch formula here. We had this side, and then we just computed this side. Okay, so we have that. So this is the for threefolds says the following. It says that the Euler characteristic of E is equal to this mess. So R C1 C2 over 24 plus E1 C1 squared plus C2 over 12 plus C1 over 2 E1 squared minus 2E2 over 2 plus this big guy here, 1/6 C1 cubed minus 3E1 E2 plus 3E3. Okay, so this is the formula. Okay, this is the nice formula that we have. Okay, so let's look at some. Okay, so now we have this formula. Let's look at some special cases. Okay, so what we can do is we can actually look at when we're looking at E is equal to O of X. Okay, so then the rank is 1, so this becomes 1, and then the higher Turing classes vanish. So this vanishes, this stays. Let's see, this vanishes. I think that's pretty much it. So we have that chi of O of X is equal to, and then we have here, so we have R1, or sorry, 1, we have C1, C2 over 24, plus, so this is E1. Okay, this is trivial, right? So this is the trivial class. So the first Turing class of this of E is 0. So this is actually 0. And then, so 0 plus, here, this goes away. So we have C1, and so E1 and E2, so let's see. So E1 and E2 are 0 as well, right? So, this is an E, right? Yeah, this is an E. Okay. So, this is 0. These are all 0 as well. And then this thing here is 0. Okay, so this is our formula for the Euler characteristic here. So this could maybe be written, we can clean up this formula here, and we get that chi of E is equal to rank times so in general again, chi of X plus stuff. Okay, let's try and clean this up a little bit more. So let's actually look at the case of divisors. Okay, so in the case of divisors, okay, so suppose, so let's look at the special case that E is equal to OX of D, okay? And then this means that E1 is going to be equal to D, and then EI's are going to be 0 for I greater than or equal to 2. Okay, and this looks a lot nicer as well. So then we have, so chi of D will be equal to, so the rank is 1. Then we have chi of O of X plus, and then we need to look back. Okay, so this is just going to be equal to D. This is going to be D as well. So we just have these two terms, and then we have this term here as well. So we have D. Okay, so we have D. So we have D times C1 squared plus C2 over 12 plus the next term is D over 2. Then we C1 over 2. So this is the negative canonical class. D squared over 2. And then what do we have next? Next we have plus 1/6. Let's see, plus 1/6. So now we have D1 cubed. Okay, so this is kind of nice looking as well. So let's remind ourselves that the C1 of T of X is equal to negative C1 of omega 1 of X. And when you take the top term class, this is negative C1 of the determinant of omega 1 of X. So this is just equal to the negative of the canonical of X. Okay, so we have this, and what does this tell us when we put this into the formula? So we have this magic C2, whatever that is. Okay, and then we have the canonical here. And so this becomes here, this formula becomes chi of O of X plus. Okay, and now maybe we can factor some things out. So here we can do C1 times D. Okay, so C1 times D, and then here this is 4 of these. So let's see this. So this is 4 of these in the denominator. So we can do 3 over 3 here. So we get 12. And then what do we get? So so this is 12. So this is all plus. Okay. So this is equal to so oh, this is a minus here. So this is so d dot k of x over 12. And then so this one is equal to so we had this k of x here, and then here we had 3 times this whatever was left over here, which was d. So minus, so we had a minus here, minus 3d. Okay, plus, so not d1, plus d. Okay, and then we had the 12, so I could say plus 2d cubed. Okay, so this is kind of a nice formula. Let me write it out neatly. Okay, so the other nice, neat formula is the following. Is equal to O of x plus, and then we have so d dot k of x, k of x minus 3d plus 2d cubed, all divided by 12. So they all really have a d in them? So they all have a d. So I guess I could factor out another d if we wanted. Yeah, whatever. Okay, so this is the formula here, and so this is the formula for this is so Riemann-Roch for 3 folds.